All right, so a small breather question, fairly simple one. So you've got a bar, horizontal bar, with a pivot point, and so that's 25 centimeters, that's 75 centimeters. We're given that the force on this end is 10 newtons, the force on this end is 8 newtons, and it asks what is the net torque. So torque is F cross R. So the torque due to the 10 Newton force is 10 newtons, which we can decompose this into FR sine theta, where theta is the angle between them. So R here is 0.75 meters. And if we line the force and the R vector up tail to tail, we see that it's 90 degrees. Sine of 90 degrees is 1. We need a directionality though, so we point our fingers, for the right hand rule, we point our fingers in the direction of the force, our palm in the direction of the angle to breach the R vector, and then our thumb points in the direction of the torque. So in this case, it's inside into the page, and so I will actually call this a negative torque. So this should be a negative. So this would be minus 7.5 Newton meters. So our torque to our 8 Newton force is 8 newtons cross with our R, so times our 0.25 meters. And again, we have our force, we have our R vector, and we use the right hand rule by pointing our fingers in the direction of the force, our palm in the direction that goes towards R, and our thumb points in the direction of the force. And in this case, it's out of the page, which I'm defining as a positive torque. So this is 2 Newton meters. And I'll give it a K hat just to keep them straight, which also means that these are vector quantities now. And so then our net torque is minus 7.5 Newton meters K hat plus 2 Newton meters K hat, which is minus 5.5 Newton meters K hat. So there's my net torque. Checking the solution here. We do indeed get 5.5. They didn't bother with the directions, but it's in a counterclockwise, so negative torque would invoke a counterclockwise direction, at least the way I've defined it here. So that looks good.